Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the disk management in operating systems. Disk formatting, low level formatting or the physical formatting. Before a disk can store the data, the sector is divided into the various partitions. This process is called the low level formatting or the physical formatting. It fills the disk with the special data structure for each sector. The data structure for the sector consists of header, data area, that is usually the 512 bytes in size, and the trailer. The header and the trailer contain the information used by the disk controller, such as sector number and an error correcting code, that is represented as ECC. Next one, this formatting enables the manufacturer to test the disk and to initializes the mapping from logical block numbers. Next point, to use a disk to hold the files, the operating system still needs to record its own data structures on the disk. It does not so into two steps. First step is partition the disk into one or more groups of cylinders. Next point. Among the partition, one partition can hold a copy of the OS executable code while another holds the user files. Next partition method is second step is the logical formatting. The operating system stores the initial file system data structures onto the disk. These data structures may include the maps of free and allows them and an initial empty directory. Next one is boot block. For a computer to start running, for instance, when it is powered off or rebooted, it needs to have an initial program to run. The initial program is called a bootstrap program, or it should be simple. It initializes all the aspect of the system from CPU registers to device controllers and the contents of the main memory, and then starts the operating systems. Next point, to do this job, the bootstrap program contains the 3 points. First one is finding the operating system kernel on the disk. Second one, loads the kernel into the memory. Third one, jumps to an initial address to begin the operating system executions. Next we have the advantages. First advantages is ROM needs no initialization, that is read only memory needs no initialization stages. Next one, it is at a fixed location that the processor can start executing when powered up or reset. Third one, it cannot be infected by the computer virus since the read only memory is read only. Fourth one, the full bootstrap program is stored in the partition called the boot blocks at the fixed location on the disk. A disk that has an boot partition is called as bootstrap on the system disk. Next advantages is the code in the boot ROM instruct the disk controller to read the boot block into the memory and then starts the executing that code. Next one is bootstrap loader that loads the entire operating system from one location on the disk and to start the operating system running. Next topic is bad blocks. The disk with the defected sector is called as bad blocks. Depending on the disk and the controller in use, these blocks are handled in a variety of ways. First method is handled manually. If blocks go bad during the normal operation, the special program must be run manually to search for the bad blocks and to log them away as before. Data that resisted on the bad blocks usually are lost. Second method is sector sparing or forwarding. The controller maintains a list of bad blocks on the disk. Then the controller can be told to replace each bad sector logically with one of the spare sectors. This scheme is known as sector sparing or forwarding. Third method is sector slipping. For example, suppose the logical block 17 becomes a defective and then the first available spare follows the sector 202. Then the sector slipping would remap all the sectors from the 17 to 202, moving them all down to the one spot. Thank you.